Hi, and welcome to the video breakdown of my AI for Games coursework 1. This is my implementation of the Dijkstra and the A-star pathfinding method for grids and also for graphs. You can actually play this on your browser. I'll include a link to the itch.io in the comments. It's not really a game or anything, but it's quite interesting, I think, but I will get straight into it. And starting off here, we have the grid implementation. Now you have a few options here. For example, I'm starting on the Dijkstra. The distance type, this only really plays into account for the A star because it defines heuristic distance. So that is not super important for Dijkstra. And then you just have some stats about the current computation that's gone on, so how long the function took and how many nodes were searched, how long the path is, and whether or not the path was complete. Now I've included that because say you have a fully walled off section here and you try and get the place inside of it, you can see now that that path is marked as incomplete because there's no way to go from here, the starting node, to where the mouse is in the middle of this ring, since it's fully surrounded by walls. But building off of that, you can see you can place down walls here and create little mazes. I'll just create one quickly now. Okay, so I've made this quick little maze here, and you can see wherever you put the mouse, it very quickly solves the optimal path there using the Dijkstra method. It's taken a matter of milliseconds. Now I can switch over to the A star, and I mean visually you're not going to see much of a difference, but this one is using the heuristic distance there, and this is where that distance type comes in. So I can change this to like hexagonal axial, which I kind of explain more in my report, but it's just ways of measuring the estimate distance. If I reset, you will see some big impact on the A star and Dijkstra when the graph is more empty. For example, if I come up here, you'll see that I search 168 nodes before I find this target node up here. And in fact, if I come over here even more so, I search 224 nodes before I find my target node up here. This is because the Dijkstra method is of course an uninformed search, so it doesn't actually know where it's going in relation to where it is. It just searches the local best choices. However, if I come over to the A star method and I come up here, remember we were on 224 nodes searched and now we're on 21, which is the exact amount of nodes needed to reach this position. That's because the A star has also got that heuristic element coming in as well, which gives an estimate of how far the current point is from the target point. And of course, if you don't have things like walls in the way, that's pretty much going to be a direct path, and it's not going to really stray from that at all. If we were to have a wall in the way, say here, we get a few more, but really not that many more, only 37 nodes. Whereas were I to come in with the Dijkstra, come in here, you can see we're still up at a very high number of 217 nodes searched. That's pretty much the the grid-based implementation that I've created. Again, fully interactable, so if you want to give it a go, the itch link is in the comments, is in the description below. But for now, I'll switch over to my graph mode, and this is quite different looking. You can see again, we're in the Dijkstra method. We have Manhattan distance. I'm actually going to go ahead and change this to Euclidean, and I go into Y in my report, but Euclidean distance is actually how I calculate the G cost. And it's very important that the G cost and the heuristic stays the same. We also have another option here, which is this shouldn't be labeled as distance type. I need to update the upload for the itch, but this is the road speed. So for example, I can have a road from here to here, and it could be medium, and I could have a road from here to here, and it's fast. And what the fast does, or the medium, is it multiplies the distance of the path, giving you like a variable influence. So fast roads are their distance times 1, medium roads are the road distance times 2, and slowest times 3. I just thought it was interesting to include. And so for example now, even if I put probably a house here and here, and make some fast roads between these houses and slow roads between these houses. Oh, I meant to put medium. If I set this one as my start and this one at my end, despite you can see there's more physical space being taken up by this road, it actually prioritizes taking this path because it's got a lower distance, but it's not really distance. It's got a lower effective distance, I suppose. And this could be contextualized in a game as maybe higher quality roads or difference between like national roads and city roads and motorways that allow for different max speeds. So maybe it's quicker to take the longer route on the motorway because you can go at a higher miles per hour than you could on a lower on a quicker route that goes right through the middle of the city, and you can only go at 20 miles an hour. If I reset here, I'm just going to set up a very basic node graph here. It's really not going to be super interesting results, but I find it very useful for demonstrating, switch to Euclidean, the difference between Dijkstra and A star in graphs as well. And I'm going to go ahead and swap over and finish out all these roads. Here we go. So I'm going to set this house over on the left as the starting house and this house over on the right as the finishing house. Now, see how it's generated the obvious path that we thought right down the middle, but it's checked 10 nodes, interestingly. There's only 5 nodes on this path, I suppose, if you count the starting node. 4 roads, but it's checked 10. And now if we switch over to this A star, we are going to see again this drops down to 4 nodes, which is the exact amount it needed to reach the final position. That's because the Dijkstra method is coming in and it's actually checking some of these ones that obviously from our human perspective we can tell they're not going to be the fastest route because of how they relate to the final point. But again, the Dijkstra method is not able to have that insight to how a point is estimate relative to the target. So with the A star method we get that straight path, and with the Dijkstra method we get some of these explored, and then it finally finds the path in the middle. Again, I would implore you to give this a go. I find it quite interesting. Thank you very much for watching the video, and I will gladly take any questions in the comments below. Thank you very much.